So our lesson for today is all about equations still, but more specifically, understanding what a solution to an equation is, right? So up until this point in our conversations about what an equation is and some things that we've been doing, we've discussed, combining like terms. We discussed distributive property. We discussed a combination of those things. And each time that we come in, I kind of discuss, why are we doing this? We're building up our skills and we're building up these processes to be able to eventually solve equations using these ideas. Okay. Now what we're going to do is eventually start solving these equations, but we want to make sure we know what a solution is, because this process right here will not only help us check our answers to solutions, but also understand, well, what are the steps I need to take in order to simplify, go through, and solve. All right. So if you're taking a look here, a lot of the questions will be posed this way. It says, determine whether y is a solution to the equation. They'll give you a couple different values to work with, and they'll give you an equation. All right. All you're going to do is take those y values, each individual y value, plug it into this original equation, and you're going to check to see if you get the same thing on both sides of that equation sign. If you do, then it is a solution. If you do not, then it is not a solution. And there's going to be times where you don't have any answer, right? And there's going to be times when all of these answers work, okay? So just kind of be aware of the different solution types that you might see on your ALEKS assignment and moving forward, on the next knowledge check as we go through with equations and things like that. But let's go through this process. And for these, we can kind of work a little bit more collaboratively. There's not really, any new skills for us to learn. It's a lot of just using our basic operations to help us solve. All right. So what I would suggest doing is just taking it one value at a time, right? You see in my list there, 4 is the first y value. I'm going to take 4 and plug it into my equation. So instead of 10 is equal to 4 minus 3y, I'm going to have 10 is equal to 4 minus 3 times 4, just taking 4, plugging it in wherever I see a y. Well, on my left-hand side, I just have a number. Nothing's going to change, right? On my right-hand side, I have to make sure I know what to do first, right? I need to take care of any multiplication and division before I do any addition and subtraction. So what is 3 times 4 going to give me? 12. So I have 4 minus 12. And what's 4 minus 12? 9. Positive or negative? Negative 8. Well, if you have 10 of something, is it the same thing as having negative 8 of something? No, right? I don't have the same thing on either side of my equation sign. So y equals 4 is not a solution. All right. I'm just going to put an X there so I know it didn't work out. Now I'm going to transition to the next one. So I have 10 is equal to 4 times, 4, erase this here, 4 minus 3 times negative 7. Again, the 10's not going to change at all. What's negative 3 times negative 7? What's a negative times negative? Positive. And what's 3 times 7? 21. So now I have 4 plus 21, which gives me what? 4 plus 21. 25. Notice again, I have something different on either side of my equation sign. So when I'm trying to determine whether something's a solution, would you say that negative 7 is a solution or is not a solution? What's that? Well, do I have the same thing on either side? No. So then it is not a solution. So when I plug negative 7 in and I don't get the same thing on either side, again, that's also not a solution. Like I said earlier in class, they're probably going to give you a list of 3 or 4 values to plug in and check. You want to make sure that they give you the same thing on either side. There's going to be times when none of them do. Let's see about negative 3. 10 equals 4 minus 3 times negative 3. Well, what's negative 3 times negative 3? Positive 9. And what's positive 9? Plus 4. Is having 10 things the same thing as having 13? No. So then would you say negative 3 is a solution or isn't a solution? Isn't, right? So given these values, everything that we plugged in actually didn't work, right? So none of those values would be solutions, okay? And eventually what we'll be able to do is take that equation and solve it for y to find exactly what the solution is. But for right now, we want to kind of get a basis of what the steps are to help solve and choose values that will become solutions, all right? Everybody good with that first example? That's pretty much the question that you're going to get. It's going to give you an equation, list of values for X or Y or whatever the variable is, plug them in. If it's the same on either side, you're good. It's a solution. If they're not, then it is not a solution. All right. Let's take a look at another example. Totally different equation, totally different list of values to plug in. Okay. I have 9x minus 1 equals 17. And they want me to check, is 5 a solution? Is 2 a solution? Is negative 8 a solution? All right. Well, we're going to go through the same process. So wherever I see an X now, I'm going to plug in 5. So that's the first one I'm going to test. Like I said, when you go through this, take one value at a time to plug in. Right? Then take care of your multiplication division and then your addition and subtraction. So what's 9 times 5 going to give me? $45. What's 45 minus 1? 44. So I have 45. 44 is 44, the same thing as 17? No. So then what would we say? What's that? It's not a solution. Well, what's not a solution? 5, right? The value that we plugged in is not a solution. So no, this isn't a solution. Let's move on to the next value. Plug in 2. So instead of 9x minus 1 equals 17, I have 9 times 2 minus 1 equals 17. Well, what's 9 times 2? 18. What's 18 minus 1? 17. And for the first time, I have the same thing on either side of my equation sign. So what this means is that 2, in fact, is a solution. So when you plug in 2, you get the same thing on either side of your equation sign. So it works out that it is a solution. And we're good. Okay. Some equations have multiple solutions though, right? So we can't just stop there after we get one solution. We need to continue to check all of them. We're going to plug in that last value, which is negative 8. Again, make sure that you're doing your multiplication and division, then your addition and subtraction to help you simplify. So what's 9 times negative 8? Well, first off, what's a positive times negative? Negative. So I know this is going to be a negative number. And then what's 9 times 8? If you need to use a calculator, you can. It's 9 times 8. What's that? 70. 72, right? Well, now I have negative 72 minus 1. Think back to what Ms. Smith said yesterday, right? With our integer rules. Negative 72 minus 1, what's that? Negative 73, right? When they're the same sign, you add them together, and then you just keep the sign of the higher one, or yeah, you just add them together. You keep the sign in front, so it's negative 73. Right, exactly. And then keep the sign of whatever the higher number is. So is negative 73 equal to 17, or there's the same number on either side there? Absolutely not. So it is not a solution, okay? So negative 8 is also not a solution. So the only solution that I have here right now is x equals 2, okay? Like I said, this is essentially what your entire assignment's going to look like. They're going to give you a list of values. You're going to plug them in and try and verify which are solutions, which are not, and then choose from there, okay? Are there any questions about anything that we covered today? Anything related to this topic? We will eventually expand on this, and instead of giving some values to choose, we're going to have to recreate them by actually solving this equation. But we'll get to that in a little bit. We're almost there, almost on our path to solving. Does anybody have any questions at all, though, about this little mini assignment? Everybody good?